All right, in this video, we're going to take a look at domain and range of tangent and cotangent. So we took a look in the last video of the graphs and the fact that they don't have amplitude. The period is pi, or pi divided by b. And then the phase shift and vertical shift are the same as they were for sine and cosine. So in this video, we're going to focus more on the domain and range of tangent and cotangent, in particular, the domain. So for tangent, tangent of an angle is y divided by x. On the unit circle, it's the y coordinate divided by the x coordinate. And if we take a look at this fraction here, notice we have an x in the denominator. Now, we get vertical asymptotes for tangent because there are some angles in that circle, in our unit circle, in which the denominator, the x-coordinate, is 0. And again, if we take a look at the coordinate plane, your x-coordinate is 0 means that you actually end up on the y-axis, where your x-coordinate is 0. And so on the y-axis, this has an angle of pi over 2. And down here, it would be 3 pi over 2. So notice if we end up on the y-axis where this x-coordinate is 0, we're going to get undefined, which by its very nature, because these are not common factors here, is going to be a vertical asymptote, just like we saw with graphs of rational functions. So at pi over 2 and 3 pi over 2, and even negative angles as well. Here's negative pi, negative 3 pi over 2. So it's going to be the odd multiples of 90 degrees, or pi over 2. And as we get closer to those vertical asymptotes, our graph's going to go up and up and up forever, or down further forever. Again, never touching, never crossing these vertical asymptotes. With cotangent, here's the graph of our cotangent. Notice here we have a y in the denominator. So when is y in the coordinate plane? When is your y value 0? When are your y coordinates equal to 0? Well, your y coordinates are 0 if you're on the x-axis, like 0 or 180 or pi or 2 pi or 360, or just keep jumping back and forth from the positive side of the x-axis to the negative side of the x-axis. And so those values there that cause y equal to 0, those are going to be vertical asymptotes for cotangent. So we have it at 0, pi, 2 pi, 3 pi, or even if we go negative pi, negative 2 pi, negative 3 pi, so we get multiples of pi. So for the graphs of tangent and cotangent, as far as the vertical asymptote equations are concerned, for tangent, it's going to be odd multiples of pi over 2. So, and again, that's where your x-coordinate is 0 when you're on the y-axis, or pi over 2 if you check your unit circle. Which means we don't want to equal those values, so it's not going to equal pi over 2 plus pi times k for some integer k. So what this is right here, this pi over 2 plus pi times k, is actually a sequence rule. It's an arithmetic sequence, if you want to be precise, where the common difference is pi, and k represents an integer. Kind of like we could use n's a lot for sequences, or i's or j's or k's. But in this case, we can also have k be a negative integer as well. So we can also go backwards on the x-axis if k is negative. Again, noticing that with tangent, we have this pi over 2, this y-axis here, because we want to make sure that x doesn't equal 0. It will equal 0 if you're on the y-axis. So that's why we have this pi over 2 part, and then every pi radians are 180 degrees. That pi times k, that's just going to alternate between going from the positive y-axis to the negative y-axis. As far as the range is concerned for tangent, every y value will be on one of these tangent, for lack of a better term, a propeller blade. So your range for tangent and your range for cotangent as well is all real numbers. So those are just real quick and easy questions there for the range. Cotangent, notice that every pi radians are 180 degrees. We're going to get a vertical asymptote. And again, that's because your y value is 0, means you're on the x-axis. So you have 0, pi, 2 pi, 3 pi. Even going the opposite way, 0, negative pi, negative 2 pi, negative 3 pi. Remember, our negative angles rotate clockwise or to the right. So with cotangent, we're going to take our what we're taking the cotangent of and make sure it doesn't equal pi times k. And we might see some phase shifts and some period changes which affect what's going to go on the right, or on, excuse me, on the left side for each of these. All right, so let's take a look at those examples. We have in part A 2 times the tangent of x minus pi over 4. Well, here we get a pi over 4 shift to the right. And when you shift it to the right pi over 4, you also shift those vertical asymptotes to the right pi over 4 units as well. So even the vertical asymptotes get affected by phase shifts. So for tangent, remember tangent is x over y. And we're really focusing on this y. We don't want that to be 0. Y is going to be 0 if you're on the x-axis. So again, if we look at for tangent, oh no, tangent, excuse me, I'm sorry. Tangent is y over x. I had it backwards. Sorry about it. Tangent is y over x. And so we want to know where x isn't 0. Well, where it is 0, it's going to cause a vertical asymptote. That's on the y-axis. So the y-axis is your pi over 2 on the y-axis. So for this one, we're going to take the x minus pi over 4 and make it not equal, that's a 4, to that pi over 2 plus pi times k. And we're going to solve for x. We're going to add pi over 4 to both sides, which is the phase shift to the right. So when you add the pi over 4 to both sides, that's when you shift it to the right. And let's see what we'll have. So we'll have x can't equal pi over 2 plus pi over 4 is 3 pi over 4. Plus pi times k. These are like terms, the pi over 2 and the pi over 4. So x can't equal 3 pi over 4 plus every 180 degrees or pi radians thereafter. And we'll take a look at the graph of this in just a moment. But for the range, again, 2 tangent x minus pi over 4, the range is all real numbers for tangent and cotangent. It's never going to change. So we can just have range be negative infinity to infinity for all of these examples. So it's going to also work over here, and it's going to work over here as well. As far as the graph is concerned, here's the graph of tangent of x minus pi over 4. Notice that normally tangent starts at the origin, but it shifted it over pi over 4 units to the right. And if we take a look at our vertical asymptote's now at 3 pi over 4. It used to be at pi over 2, which is going to be it's going to be halfway between the pi over 4 and 3 pi over 4. So maybe right about here was our vertical asymptote, and then it moved it over to this point right here. So again, the vertical asymptotes are affected by phase shifts as well. All right, part B, we're going to cotangent. This one is x over y. I, again, apologize for that. I had a bit of a old person moment there. This one is x over y, so we want to know where y would be 0. That would be a vertical asymptote. And again, y is 0 means you're on the x-axis. So here we just have an x, which is really nice. So for our domain, x just can't equal pi times some integer k. And we already covered the range. We can just copy it for all three, so we're done there. All right, part C. Here we have 2x plus 2 pi over 3 inside parentheses. So for the domain in part C, we're going to take 2x plus 2 pi over 3 and make sure it doesn't equal. We got tangent, which before we said was y over x, and that's this pi over 2 because we don't want x to be 0, which is on the y-axis. So we're going to have vertical asymptotes for this function starting out where we have the y-axis pi over 2 and every 180 degrees or pi radians thereafter. All right, so solving for x, the first thing we're going to do is subtract 2 pi over 3 from both sides. And when we do that, we're going to get 2x equals pi over 2 minus 2 pi over 3 is 1/2 minus 2/3, and then we'll put the pi back when we're done. 1/2 minus 2/3 is, I believe, negative 1/6. So negative pi over 6. Check me on that. All right, now we got to get this x by itself. So we're going to either multiply everything on both sides by 2 or by 1/2, or divide everything on both sides by 2. Or if it's easier for you, maybe do one of them times 1/2 and the other one divided by 2. So negative pi over 6 divided by 2, or negative pi over 6 times 1/2 is negative pi over 12. That's about negative 15 degrees, if you're wondering. And then plus pi over pi times k all over 2, or 1/2 times pi times k. I like to write it as pi over 2 times k, because this would be every 90 degrees or every pi over 2 radians, starting at negative 15 degrees or negative pi over 12, and then adding and subtracting pi over 2. So these are going to be our vertical asymptote equations to generate a sequence of vertical asymptotes. And that's all this is, just a sequence. So, all right, that about